Alrighty, I'd like to show you an example of a more difficult logarithmic equation. I'm assuming you've had some experience with logarithms and combining them, converting them from a logarithmic equation to just an algebraic equation. But here's a situation where you have a logarithm on the right side of the equal sign and one on the left side of the equal sign here. Here's the equal sign. Now you cannot combine two logarithms that are on the opposite sides of the equal sign. So let me tell you what I'm going to do verbally, and then I'll show you the solution. I'm going to take the logarithm on the right, this guy here, and I'm going to add it to both sides, and then I'm going to combine it with this one. Once I combine the two logarithms into a single logarithm, then I'm going to convert it to an algebraic equation. And then once I do the conversion, from there on out, it's all Algebra 2 skills. So let me show you a solution. And at the very end of this problem, there's a little twist, a little plot twist that's going to frustrate some of you because you may spend 2 or 3 minutes solving an equation and end up getting the correct answers to the algebraic equation, but it actually doesn't solve the original logarithmic equation. So let me show you what I mean by that. So here is the original problem. And I told you what I was going to do is I was going to take the logarithm on the right side of the equal sign. I was going to add it to both sides. So when I do that, this whole thing cancels. Okay. And on the left side, I have two logarithms being added together. Now there is a property that allows me to combine two logarithms that are being added if you multiply the input. So notice that the x plus 19 and the x minus 5 is being multiplied. So the first step is I added the right logarithmic piece to the other side. Okay, and then I combined. Since they are being added, I multiply. Okay, and then once I get there, now I can take this guy and convert it to an equation. So the base of the logarithm is 3. 3 to the 4th power equals the inside stuff of the log, which happens to be this. Now, once you convert it, this whole stuff here is all algebra. Okay? So, 3 to the 4th power is 81. And then the product of these two binomials, if you do FOIL, first, outer, inner, last, you get first, outer, inner, last. Okay, and then I'm going to set this whole thing equal to 0 and factor it. So I'm going to subtract 81 from both sides. So if I subtract the 81 from the negative 95, I did a little side scratch work over here. I had to actually do some computation. I couldn't do it in my head. So I got 176, but that's a negative 95, and I'm subtracting 81, so it's a negative 176. So we end up getting a trinomial here. When I combine the 5x and the negative 5x and the 19x, that gives me a positive 14x. Now, this part was a little bit tedious for me because I don't know my multiplication tables up to 176, but whenever you're factoring a trinomial, you have to find two numbers that multiply. If you look over here on my little diamond here, they have to multiply to get that last number, but they have to add to get the middle number. So I fiddled around with my calculator, and I just kept trying, like 19 times 5, 20 times 6, and I kept trying numbers. 21 times 14, that didn't work. I did 22 times 8 and so forth. Actually, all those that I just mentioned, I just were making up off the top of my head. But if you notice that they have to multiply to get a negative 176, but they have to add to get a positive 14. So one of my factors here has to be negative, okay? The larger of the two has to be positive because they have to add to get a positive 14. So these are factoring skills from Algebra 1. but the numbers are pretty large to work with. So here we go. We just have to deal with it. This problem took me a little bit of time to just fiddle around with the factors. So I got a positive 22 and a negative 8. Both of those numbers add to get 14, which is the middle term, and they multiply to get a negative 176. So if my factors are x plus 22 and x minus 8, that means that my solutions have to be negative 22 and positive 8. Okay? Now here's the plot twist. This is my solution set. Okay? So when MathXL asks you for a solution set, they're asking for the numbers that make the equation true. But keep in mind, you're not trying to solve you're not trying to solve this algebraic problem. You're trying to solve the original logarithmic question. Okay? So the question is negative 22 and negative 8 a solution to the original problem? The answer is no. Only one of them is. And here is the plot twist. In the lower left-hand corner, this is a fact you need to know. The logarithm of any negative number is undefined. Notice when I take the negative 22 and I plug it into the original problem, negative 22 plus 19 is a negative 3. Log of a negative 3 is bad. So we take this solution and put it in the trash can. It doesn't work. If you take the 8 and you plug it in here, you plug it in here, you end up getting a log of a positive number, which is okay. So the only solution we have is the 8. We're going to keep that. That will be our solution set. So once again, this is a logarithmic equation more on the difficult side. It involves lots of algebra. And then at the very end of the problem, you have to make sure that your solutions are not what's called extraneous. Extraneous means extra or no good. So we would say that negative 22 is an extraneous solution to this equation. Even though it solves the algebraic equation, it doesn't solve the original logarithmic equation.